Hello everyone. In last two parts we have already seen the nucleophile is carbanion and this carbanion is added to carbonyl compounds. So the reaction was aldol reaction. That is the first reaction where the nucleophile is carbanion. So depending on the compound, that is the reagent from which we are generating the carbanion, depending on that there may be different types of reaction. That is why there are different name reaction. Okay. So today we will explore Perkin reaction. So in this reaction, generally aromatic aldehyde is taken. So it is specific for aromatic aldehyde. Why? Because here the final product that is generated, there is CC double bond and aromatic ring that is adjacent to this CC double bond. So there will be conjugation. So because of this conjugation, the product, it gets stability, and this stability will drive the reaction towards forward direction. That is the first reason. And the second reason is, if it is aromatic aldehyde, that means there is no alpha hydrogen, and as there is no alpha hydrogen, so aldol reaction cannot take place. That is self condensation between two aldehyde molecules that will not take place in presence of basic medium. Because here also we are using base. So our base is RCH2COO-. So here we do not use NaOH or NaOET, this type of strong bases. What is the reason behind that? We will come to that point later. So here we have taken RCH2COO-. It may, that is R group, it may be any alkyl group, fine. Now here the main important thing is the anhydride that we have taken. This is our anhydride. The carboxylate salt. So this is our carboxylate salt. So this carboxylate salt, it must be corresponding to the anhydride that is generally used. Fine. So this carboxylate salt, that is RCH2COO-, and here also we have taken RCH2COO-COCH2R as anhydride. So this fragment is same for both, right? If you consider, sorry, up to this part, if you consider, this is same, right? So if it is R in case of anhydride and R prime in case of base, we cannot take that reagent. Okay. So this is very important. What is the reason behind that? We will also discuss that. The product here is alpha beta unsaturated aromatic acid, and these are the byproducts. Fine. Now we will see the mechanism. First, this is our base. Now we have taken here CH3COO- Na+. Okay, sodium acetate we have taken, and this is anhydride. Now these three alpha hydrogen, both sides, these are acidic in nature because of this carbonyl group. So the base, it will capture this hydrogen and there will be negative charge generation. So this is our carbanion. Now this carbanion, there another resonance structure is present, which is this one. Now the negative charge is over oxygen. So both structures are possible. Now next, this carbanion, this is our carbanion. It will react with, because it is the nucleophile, this is our nucleophile, it will react with the aromatic aldehyde compound. For the aromatic aldehyde we have taken here benzaldehyde, PHCH. So this carbanion, it will react with carbonyl, negative charge over oxygen, and this negative charge, so this is the nucleophilic addition of carbon. This negative charge, it will attack this carbon of the other COCH3 group, which is present in the right hand side, that is this carbon. Now there is negative charge over oxygen. Now this negative charge, if it is pushed back, then what will happen? There will be internal transfer of acetyl group. So acetyl group is this group, COCH3. So this COCH3 here, it is attached with this green oxygen, which is basically the oxygen of anhydride. But after this step, now the COCH3 group, it is attached to this blue oxygen, which is basically the oxygen of aromatic aldehyde. So this is the internal transfer of acetyl group. And finally what will happen, this acetyl, that will be removed and this hydrogen will also be removed. So this CH bond will be broken, there will be CC double bond and this CO double bond, that is also broken. So finally there will be negative charge over here, but as if you consider this hydrogen, it will be CH3COOH, where one oxygen is, that is this oxygen, it is coming from the aromatic aldehyde. Now see, if this second alpha hydrogen is not present, why I am calling it second alpha hydrogen? Because the first alpha hydrogen, that is already removed in the during Carbanion generation, right? So this is the second alpha hydrogen. But if this alpha hydrogen is not present, then this step is not possible. That is elimination of acid, that is not possible. So this is the support of the mechanism, because when there is no alpha hydrogen or one alpha hydrogen, we will not get any product. And this is the support of the mechanism. This is in support of the mechanism. Fine. And finally we are getting alpha beta unsaturated acid, and this acid is basically cinnamic acid. Okay, so here the driving force is this CC double bond, which is in conjugation with this PHD. That is why aromatic aldehyde is always preferred. Now we have this question, that why the carboxylate salt corresponding to the anhydride is generally used in Perkin reaction. So suppose we have taken this salt, that is R prime CO2 minus Na plus, and our anhydride, there is COR group, but this is COR prime. So these two are obviously not same. So if this is the case, then this type of exchange may take place. So now this negative charge over R prime COO minus, it is attacking the anhydride carbonyl. As a result, negative, this bond is broken, negative charge over oxygen. Now we are getting sodium salt of RCO2H. So this type of exchange, because of this type of exchange, we are getting two different type of anhydride. This is from this anhydride we have started. This is the second anhydride that we have obtained because of this type of exchange. So both the anhydrides will react with the aromatic aldehyde, and we will get mixture of products, which is obviously not wanted. Okay, that is the reason carboxylate salt corresponding to the anhydride is used. And next question is, why we do not use sodium ethoxide or NaOH, that is strong base, is not used. What is the reason behind that? If strong base is used, first of all, in presence of strong base, there is a chance of aldol reaction. If there is alpha hydrogen, there may be carbanion generation, and this carbanion can react with another aldehyde carbonyl molecule, because our aromatic aldehyde, that is aromatic aldehyde, aldol reaction is not possible because there is no alpha hydrogen. But we know that there is alpha hydrogen in anhydride. So strong base will cause that problem. And the second reason is, if we use strong base, that is OET minus, which is generated from sodium ethoxide, this can attack CO, negative charge over oxygen. Now this negative charge, when it is pushed back, there will be negative charge over this oxygen, so this bond is broken. So from this side we are getting RCO2O minus, and from the right hand side we are getting RCO2ET. So anhydride in this way is decomposed, and if anhydride is not there, we cannot get our desired product. So this is the reason. So this first example is with ethoxide, second example is with HO minus hydroxide, which is coming from sodium hydroxide. Same kind of exchange reaction is taking place. Fine. So anhydride will be destroyed. That is the reason we do not use strong bases. Now we will see some examples of Perkin reaction. Now during the mechanism, we have already seen that our final product is cinnamic acid, but here our starting material is cinnamic acid. Sorry, it is cinnamaldehyde, not cinnamic acid. Okay, so why we have taken this? Because though there is CC double bond, but we just need this CHO group. Okay, it is not just aromatic aldehyde, it is aromatic conjugated aldehyde, alpha beta unsaturated aldehyde. Okay, and here also we do not have enolizable hydrogen, alpha hydrogen. That is the reason we can take this compound as our starting material, and we are using acetic anhydride and sodium acetate. So this part is coming from aldehyde, and the right hand side, the green part, is coming from the base and anhydride. Okay, next reaction, now we have taken farfural. This is aldehyde group attached to furan ring, and same reagent is we are using sodium acetate and acetic anhydride, and we are getting alpha beta unsaturated carboxylic acid. Now see, this is also aromatic aldehyde. Next reaction, now we have taken different types of different type of anhydride, and see, this is the corresponding sodium salt. Fine, so this is COET, this is also COET, and benzaldehyde is the aromatic aldehyde, and here negative charge, that is, if I write ethyl group in this way, then carbanion will be generated on this carbon, and that is the reason here methyl group is the branching. Fine, so why carbanion will be generated? Because this carbon is directly attached to carbonyl, so obviously this will be more acidic in nature, and carbanion generation is feasible here. Fine, so these are some of the examples. Application of Kumari. One application we have already seen in the mechanism, that is the generation of cinnamic acid, which is important compound. So we can synthesize cinnamic acid in, that is by Perkin reaction. That is one application, and another application is coumarin synthesis. Here we have taken salicylaldehyde. Okay, it is just like benzaldehyde, only difference is OH group is present in the ortho position. Now this is acetic anhydride and sodium acetate. So this is our Perkin product. Fine. Now there is one more step, though here it is actually not single step. I will show the steps, but actually it is removal of this H and OH, and finally we are getting this C and O is connected, and we are getting another 6-membered ring, and this molecule is known as coumarin. So how this step is taking place, that is dehydration basically. COOH. So in presence of acidic medium, actually we have to use here acid. Fine. In presence of acidic medium, this oxygen will be protonated. Now the lone pair over OH oxygen, this can attack here. So we will be getting double aromatic ring. OCH, oxygen is positively charged, OH and OH. Now there will be proton exchange, minus H plus H plus. So this hydrogen, now it will be transferred to one of the OH. So it will be OH2 plus. Now it is converted to good leaving group. And the lone pair, if it is pushed, this will be removed. So minus H2O. Now oxygen is positively charged, double bond COH, and finally there will be removal of H plus, and we are getting CO double bond here. So this is basically cyclic ester, and cyclic ester is known as lactone, and this molecule is known as coumarin. Fine. So this is the application of Perkin reaction. If you find the video helpful, please like, share and subscribe. I will meet you in the next video. Thank you for your time.